We have here, going back to rotating objects, I have an object here that has a certain velocity, v, and it's going around with angular velocity omega, and a little later the angle has increased by an amount theta, and then the velocity is here. We may now do something we haven't done before. We could give this object in this circle an acceleration. So we don't have to keep the speed constant. Now v equals omega r, so that equals theta dot times r. And I can take now the first derivative of this, then I get a tangential acceleration, which would be omega dot times r, which is theta double dot times r, and we call theta double dot, we call this alpha, and alpha is the angular acceleration, which is in radians per second squared. Do not confuse ever a tangential acceleration, which is along the circumference, with a centripetal acceleration. The two are both there, of course. This is the one that makes the speed change along the circumference. If we compare our knowledge of the past of linear motion, and we want to transfer it now to circular motion, then you can use all your equations from the past if you convert x to theta, v to omega, and a to alpha. And the well-known equations that I'm sure you remember can then all be used. For instance, the equation x equals x0 plus v0 t plus 1/2 at squared simply becomes, for circular motion, theta equals theta 0 plus omega 0 t plus 1/2 alpha t squared. It's that simple. Omega 0 is then the angular velocity at time t equals 0. And theta 0 is the angle at time t equals 0 relative to some reference point. And the velocity was v0 plus at. That now becomes that the velocity goes to angular velocity omega equals omega 0 plus alpha t. So there's really not much added in terms of remembering equations.